Welcome to our deep dive, all about natural language processing. We're focusing on how machines can understand human language, especially for you computer scientists out there.
Right.
We've got a really cool mix of sources, academic papers, book chapters, even online articles, all published between 2018 and 2025.
Trying to give you the foundation, but also what's new.
Yeah, a good blend of both.
Yes.
We'll cover how computers can tell if an email is spam, or like how they figure out if a tweet is positive or negative. And then we'll even get into how these large language models, LLMs, are, changing the game completely.
Completely.
But we're going to start with the basics first.
Yes.
And to help us with that, we have an expert here who's amazing at breaking down complex information, making it, easy to understand.
Well, I try.
So let's jump right in.
All right.
We'll start with this 2018 paper that lays out 6, I guess you could say, like fundamental elements of text classification. A great starting point to see how this field has evolved.
Yeah, it's a really good foundation. And actually, these 6 elements, they kind of show the order in which things were implemented or adopted.
Oh, interesting.
So the first element, which is kind of obvious, is data collection. You need the data, right? It's the basis for any machine learning task.
It's true.
And then after that, what happens is text pre-processing. So this is kind of like when you clean up your code before you actually execute it, you need to make sure everything's in order. So it involves things like tokenization, stemming, removing those stop words.
Ah, okay. So you're kind of preparing the data so that the algorithms can do their thing, right?
Exactly. You're taking this kind of raw data and turning it into something more structured.
Okay, cool.
And then the next step is feature extraction. This is where we actually transform the text into numbers, because that's what algorithms understand, right? It's like the bridge between, your computer science background in the world of NLP.
So we're teaching computers to understand words by turning them into numbers.
Yeah, in a way.
That's pretty cool.
And then from there, we have feature selection. So just like in any complex algorithm, you have all these different variables. You want to pick the ones that are really important.
The most relevant, I guess.
Exactly. The most informative. This is where you're optimizing for efficiency, for accuracy, making sure the model doesn't get overwhelmed.
Okay, so avoid information overload, right?
Exactly.
For the model.
Yeah.
Makes sense.
Then we get to the classification stage. And this is where we actually employ algorithms to categorize our text. Is this email spam or not? What's the sentiment of this tweet? Things like that.
Ah, okay. So this is where we're answering the specific questions.
Yes, exactly. And finally, we have evaluation. So after all of this, we want to know how good our model is.
Right.
And here we use metrics that you're probably familiar with from your computer science background. Precision, recall that F1 score, making sure our model is doing what it's supposed to be doing, classifying text effectively.
Okay, so that 2018 paper, that's like the foundation, right?
Yeah.
But NLP, it's not static. It's always evolving, always changing. So what's new? What's exciting in text classification these days?
So one big advancement is using those LLMs, those large language models, for unsupervised text classification.
Ah, okay, LLMs.
And this is really interesting because these models, they're trained on a massive amount of data. I mean, we're talking huge amounts of text.
Wow.
And because of that, they can actually categorize text without needing those explicit labels.
Wait, so instead of manually labeling everything, the LLM kind of figures it out on its own?
Pretty much.
That's incredible. But I guess even with these super advanced LLMs, there are still limitations.
Oh, absolutely.
And we need to make sure we're evaluating their performance carefully.
Definitely.
Now, I'm curious about how these LLMs actually work and how they connect to this concept of word embeddings.
Right. Well, word embeddings are kind of the foundation for how these LLMs understand language. It's all about representing words as numbers. And this is what unlocks a whole new level of analysis.
It's always seemed so strange to me, like some kind of code. Turning words into numbers.
It is kind of like that, actually.
It's fascinating.
So a word embedding, think of it as a vector of numbers that represents the meaning of a word.
Okay.
So if 2 words have similar meanings, their vectors are going to be close together in this, multidimensional space, like king and queen, their vectors would be pretty close.
So the closer the words are in this space, the more similar their meaning.
Exactly. And the further apart, the more different.
Makes sense.
And this allows us to do some really interesting things. You can identify synonyms and antonyms. You can understand analogies.
Wow.
Even do sentiment analysis. And the cool thing is these embeddings, they can be pre-trained on these massive data sets.
You don't have to start from scratch every time.
Exactly.
That's a huge advantage.
It is. So Do you want to delve into some specific word embedding techniques? Like, have you heard of word2vec?
Yeah, I've heard of it, but I don't really know how it works.
So the idea behind word2vec is that a word's meaning is determined by the company it keeps, the words that surround it.
Ah, interesting.
So the algorithm looks at a huge text corpus, and it figures out, okay, which words tend to appear together, and based on these patterns, it creates vectors for each word.
So words that often show up together, they'll have vectors that are closer together.
Right.
Like cat and dog.
Exactly.
Okay.
Now, there's also another technique called fast text,
Fast text.
which builds upon word2vec, but instead of representing a word with a single vector, it represents it as a sum of character n-gram vectors.
Character n-grams.
So an n-gram is basically a sequence of n characters. Like for the word cat, the 2 grams would be k and at.
Okay.
And fast text, it takes all of these character n-grams for a word and uses them to create the embedding. And this is really useful for capturing morphological information, especially for languages like Portuguese, which have really rich morphology.
So it's like you're breaking down the word into smaller parts and considering those as well.
Exact. That's clever. And then there's GLOVE. Have you heard of that one?
Glove, I have.
Global vectors for word representation.
Right.
And this one's different from word2vec and fast text because it analyzes co-occurrence statistics across the entire corpus. So it's taking a more global approach.
So instead of looking at individual sentences, it's looking at the relationships between words on a much larger scale.
Exactly.
Interesting.
It builds what's called a co-occurrence matrix.
Okay.
Tracks how often words appear together within a certain window of text, and then uses that to create embeddings that capture both local and global semantic relationships.
Wow, a more comprehensive approach.
Yeah.
You mentioned contextual embeddings earlier.
Oh, right.
What about those?
So unlike these traditional word embeddings, where a word always has the same vector, contextual embeddings, they consider the context in which a word appears. So a word can have different vectors depending on the words that surround it.
That makes sense.
And there are models like BERT, which stands for bidirectional encoder representations from transformers that are really good at this.
BERT. Transformers. I've heard that term, especially with those LLMs.
Right. Transformers are this neural network architecture. They've revolutionized NLP. They're really good at capturing long-range dependencies in text.
Okay.
So BERT uses this transformer network to generate these contextual embeddings.
So it's using transformers to create even more nuanced word representations.
Yeah.
That's pretty cool. But why are word embeddings so important, especially for a computer scientist who wants to work with NLP?
Well, they're kind of the bridge between human language and the mathematical world of computers.
Okay.
They're essential for a lot of the more advanced techniques.
I see.
And understanding them will really help you tackle all sorts of NLP challenges.
Like you're opening up a whole new world of possibility.
Yeah, exactly.
But I guess choosing the right technique, that depends on the specific task.
Definitely.
Right.
Because each one has its strengths and weaknesses.
And things like data size, the language you're working with, your computational resources,
Right.
all those things factor in.
Absolutely.
Now, I know a lot of NLP research has been focused on English, but there's a growing movement to support other languages,
Yes.
like Portuguese, which has a really active NLP community.
It does.
What are some of the unique challenges when working with Portuguese?
One big challenge is the morphology,
Morphology.
the way words are formed.
Ah.
Portuguese has a lot of different word forms. So tasks like stemming and lemmatization,
Okay.
they become more complex.
It's like you're dealing with a much larger vocabulary.
Exactly.
Wow.
But luckily, there are resources available. Corpora, lexicons, pre-trained word embeddings.
Oh, that's great.
Things like the Portalexicon UD. It's a lexical resource that provides all sorts of morphological and morphosyntactic annotations.
Like a dictionary on steroids.
Yeah, pretty much. And then we have corpora, like the CST News corpus,
Okay.
which is a collection of news texts. And they're annotated. Annotated.
According to something called the cross-document structure theory,
Okay.
and this is really helpful for things like discourse analysis and text summarization.
Those are amazing resources for anyone working with Portuguese.
They are.
I'm glad they exist.
Yeah, they're really valuable.
Yeah.
Speaking of resources, we should talk about evaluation again.
Right.
Those computer science metrics.
Okay.
They're really important in NLP as well.
So how do we know if a text classification model is doing a good job? What should we be looking at?
Well, we use metrics like precision, recall, and that F1 score that we talked about.
Okay, familiar territory.
Exactly.
Yep.
So precision tells us how many of the instances that the model classified as positive were actually positive.
Okay.
And recall tells us how many of the actual positive instances were correctly identified by the model.
So one is about the accuracy of the positive predictions.
Yeah.
And the other is about how many of the actual positive cases you're catching.
Exactly.
And then the F1 score is a kind of a harmonic mean of precision and recall.
So it gives you a balanced measure of both.
Yeah.
Okay.
And these metrics are essential because they help us understand how well the model is performing in different aspects.
It's not just about overall accuracy.
Right. You need to look at the bigger picture.
But about how well it's doing at a particular task.
And also how well it's avoiding making mistakes.
Okay, so it's a more complete picture.
Exactly.
Now, it's important to remember that these metrics, they're not just about the technical performance.
They're not.
They have real-world implications.
They do. Imagine you have a text classification model that's being used to filter job applications.
Okay, yeah.
If that model is biased against certain demographic groups,
It could have a huge impact.
it could prevent qualified candidates from getting opportunities.
Right. It's a good reminder that even though we're working with algorithms, data,
Yeah,
there's a human element.
there is.
We have to consider that.
And that's why ethical considerations are so important. Exactly.
We need to be aware of potential biases in our data
Right.
and actively work to mitigate them.
So the goal isn't just to build a model that works,
Yeah.
but to build one that's fair
It's about responsible AI.
and ethical.
Yeah,
It's like being a responsible coder,
exactly.
but for language.
It is. We need to be critical thinkers. We need to question our assumptions. We need to scrutinize our data. And we need to create models that align with our values.
That's a great point.
Before we move on, I want to leave you with something to think about.
Okay.
Now that you have this basic understanding of text classification, word embeddings, ethical considerations, what kind of NLP project would you build?
Ooh, that's a good question.
What challenges do you think you might encounter?
Yeah,
And how would you use what we've talked about to tackle those challenges? Just something to think about.
that's a great challenge.
I hope it sparks some ideas.
It definitely does for me.
So, we were talking about LMs and how important they are in NLP.
Yeah, they're really a major advancement. I mean, think about it. They can generate text that sounds like a human wrote it. They can translate languages. They can write different kinds of creative content. They can even answer your questions.
It's amazing how fluent and coherent they are. It's like they really understand language.
Right. And a lot of that comes from their size and the sheer amount of data they're trained on.
Data is key.
It is, these models can have billions, even trillions of parameters.
Trillions.
Yeah, it's mind-boggling. And this allows them to capture all those intricate patterns and relationships in language.
So it's like having a brain with billions of connections.
It is, in a way.
And that helps them understand and generate language like we do.
Exactly. Now, you've probably heard of deep learning.
Yeah, in the context of NLP, I have.
Well, that's the engine behind these LLMs.
Okay.
Deep learning involves training artificial neural networks
Right,
with
yeah.
multiple layers, and that allows them to learn hierarchical representations of data.
So it's like building a multi-layered understanding.
Exactly.
Each layer gets more complex.
Right. And in the case of LLMs, these networks learn to represent words and sentences in a way that captures their meaning and how they relate to each other.
So it's not just about individual words, but how they work together.
Exactly. And this hierarchical representation is what allows them to perform these complex tasks.
Like text generation and translation.
Yeah, and they do it with incredible accuracy. Now, here's something really interesting about LLMs.
Okay.
They can do what's called zero-shot learning.
Zero-shot learning.
It means they can perform tasks they haven't been explicitly trained for.
Wait, so you're saying they can learn something without being specifically taught?
In a way, yes. Like, you could ask an LLM a question on a topic it's never encountered before,
Okay.
and it can still come up with a reasonable answer.
Wow. That's like they've developed a general understanding.
Right. It goes beyond specific examples.
So they can adapt and apply their knowledge to new situations.
Exactly. That's what makes them so versatile.
That's incredible.
Mm-hmm.
So we've talked about LLMs, but what about other advancements in NLP? What else is happening?
Well, one area where we've seen a lot of progress is sentiment analysis.
Sentiment analysis.
It's a technique for identifying and extracting subjective information from text.
Objective information.
Basically, it's about figuring out the emotional tone or the attitude of the writer.
Oh, so like if someone writes a review, is it positive or negative?
Exactly. Or you could use it to analyze social media posts.
See what people are feeling.
Or even customer feedback to understand their level of satisfaction.
That makes sense. So how does sentiment analysis actually work?
Well, these sentiment analysis models are trained on data sets of texts that have been labeled.
Labels.
So each piece of text is assigned a sentiment like positive, negative, or neutral.
Okay.
And the model learns to associate words, phrases, and linguistic patterns with these sentiments.
So it's like teaching a computer to read emotions.
In a way, yes.
That's pretty cool.
And the applications are vast. Businesses use it to understand customer feedback.
Right.
Political analysts use it to gauge public opinion, and social scientists use it to study trends in emotions and attitudes.
It's like a powerful tool for understanding what people are thinking and feeling.
It is now, since our listener is a computer scientist,
Yes.
we should talk about evaluating NLP systems.
Right, because how do we know if a model is actually doing a good job?
Exactly. We need ways to measure their performance.
So it's similar to evaluating an algorithm in computer science.
It is. We use metrics to assess how well they're doing.
Okay, so what are some of the common metrics in NLP evaluation?
Well, some of the most common ones are accuracy, precision, recall, and the F1 score.
Accuracy, precision, recall, F1 score. Got it.
So accuracy measures the overall correctness of the model's predictions.
Okay, makes sense.
Precision and recall focus on different aspects of accuracy.
Okay, so break that down for me.
Precision tells you how many of the positive predictions made by the model were actually correct.
So it's about how accurate the positive predictions are.
Exactly. And recall tells you how many of the actual positive instances were correctly identified.
So it's about catching all the positive cases.
Right. And the F1 score combines precision and recall into a single metric.
A balanced measure.
Exactly.
So these metrics help us understand different aspects of the model's performance.
They do. It's not just about getting the overall accuracy, right?
Right.
It's about understanding how well the model is identifying positive cases and how accurate those positive predictions are.
So it's a more nuanced view?
It is. It gives you a more complete picture of how well the model is doing and helps you identify areas for improvement.
It's like having different lenses to look at the model's performance.
Exactly. And you want to choose metrics that are appropriate for the specific task you're working on.
Right, because different tasks might require different ways of measuring success.
Exactly. And in addition to these quantitative metrics, there are also qualitative evaluation methods.
Oh, interesting.
And things like manually inspecting the model's outputs to see if they make sense.
So it's not just about the numbers.
No, it's also about looking at the actual results and seeing if they align with what we expect.
That makes sense. So we're getting a more holistic view.
We are, and this is really important for ensuring that our models are performing well and producing meaningful results.
Now, we've talked about all these advancements in NLP.
Right, LLMs, sentiment analysis, all these new techniques.
It seems like the field is constantly evolving.
It is, and one of the really exciting areas is explainable AI or XAI.
Explainable AI. I've heard that term. What is it exactly?
So in traditional machine learning, we often treat models as black boxes.
Boxes.
We input data and get output, but we don't really know what's happening inside.
We just trust that it's working.
Right, but XAI aims to change that. It's about making these models more transparent.
So we can understand the reasoning behind their predictions.
Exactly, and this is crucial for building trust and ensuring that we're using AI responsibly.
It's like being able to look inside the brain of the model.
It is in a way, and for NLP, this is especially important because we're dealing with language which is complex and nuanced.
Right, there's so much ambiguity and interpretation involved.
Exactly, so researchers are developing techniques to visualize how these models make decisions.
So we can see what parts of the text they're focusing on.
Right, and to generate explanations that are understandable to humans.
It's not just about the output, but about understanding the why behind it.
Exactly. It's about shedding light on a black box and making AI more interpretable.
And trustworthy.
Yes, especially when we're dealing with something as important as language.
XAI sounds like a really important step in the evolution of NLP.
It is. It's about making sure that these powerful technologies are used ethically and responsibly.
And that we understand how they work.
Exactly.
It's been fascinating to learn about all these advancements in NLP.
It is a rapidly evolving field.
And it seems like there's so much potential for the future.
There is. We're just scratching the surface of what's possible.
So for our listener, who's a computer scientist starting their NLP journey, what do you see as the key takeaways?
Well, first, I would say it's essential to understand the basics.
The foundation.
Yes, things like text preprocessing, feature extraction, model evaluation. These are the building blocks of any NLP application.
Like learning your data structures and algorithms.
Exactly. And then I would encourage them to explore different word embedding techniques.
Word-to-vec fast text glove.
Yes, these techniques are how we represent words and their meanings in a way that computers can understand.
So giving computers a dictionary.
It is, in a way. And then, of course, they should dive into LLMs and sentiment analysis.
The cutting edge of NLP.
Exactly. That's where they'll see how machines are becoming more human-like in their ability to process and generate language.
That's pretty mind-blowing.
It is. And finally, I would emphasize the importance of ethical considerations and explainable AI.
Right. We need to make sure that we're building and using these technologies responsibly.
Exactly. We don't want to create systems that perpetuate biases or harm individuals or society.
It's about using our powers for good.
It is.
It feels like we've only just scratched the surface. There's so much more to explore in NLP.
There is. It's a vast field.
But for our listener, that computer scientist who's just starting out with NLP, what are the big takeaways from this deep dive?
I'd say first, you really got to understand the basics.
The fundamentals.
Yeah, like we talked about. Text pre-processing, feature extraction, model evaluation. Those are the building blocks for, any NLP application.
It's almost like having a good grasp of data structures and algorithms before you can jump into building some complex software.
Exactly. A strong foundation is key. And then I'd say really explore the different word embedding techniques.
Right.
Word-to-vec, fast text, glove. Those are the tools you'll need to represent words and their meanings in a way that computers can understand.
It's like teaching a computer a whole new language.
It is. It really is. And then to really get into the exciting stuff, dive into LLMs and sentiment analysis. That's where you'll see just how powerful these models can be. Generating human-like text, understanding emotions. It's really amazing.
Yeah, those advancements are changing the game completely.
They are. And of course, never forget about the ethical considerations.
Yeah.
And that push towards explainable AI. As computer scientists, we have a responsibility to make sure that we're developing and using these technologies responsibly.
Building systems that are fair, unbiased, making sure that AI is used for good.
Exactly. It's about more than just building something that works. It's about building something that's ethical and beneficial for society.
That's a great point. So for our listeners who are ready to dive in and learn more, where should they go?
Well, the show notes have links to all the sources we've discussed, the academic papers, the big chapters, the articles.
Those are great starting points.
They are. And don't forget about the online communities.
Right, the forums, the groups.
There are tons of resources out there, courses, tutorials. You can find something for every level, whether you're just starting out or you're already an expert.
And I think it's important to remember that NLP is always evolving. So keep learning. Stay up to date.
That's the key. The field is moving fast.
Well, this deep dive has been incredible.
It has been fun.
Thank you so much for sharing your expertise with us.
My pleasure.
Yeah.
Always happy to talk about NLP.
And to our listeners, we hope you've enjoyed this deep dive into the world of natural language processing. If you're a computer scientist, we encourage you to explore this exciting field. Who knows, maybe you'll be the one to create the next groundbreaking NLP application. Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible.